Hello everyone, good morning. Welcome to our online class. So in this class, we'll solve more problems on Jacobian. Okay, so see here in the last class, we'll discuss Jacobian with three variables, right? Now in this class, we'll solve more previous year question paper questions, Jacobian with two variables. See this problem here. What is asking here? If u is equal to x square minus y square and v is equal to xy, where x is r cos theta and y is r sin theta. He gave x and y in terms of r and cos theta, okay, polar coordinates. Now he's asking show that dou of u comma v by dou of r comma theta is equal to 4r cube. He's asking, correct? So first what we have to do, we have to convert these type of problems when u comma v is given some other function. We have to convert u comma v in whatever the function is given in that mass. So u comma v he gave in terms of r and theta, right? X and y he gave r and theta. So we have to change u and v also in terms of r and theta. So what I get here? So now given u can be written as, so u is equal, x is what? R cos theta. So r square cos square theta minus y is what? R sin theta. R square sin square theta. So from these two terms, take out r square common. If I take r square common, cos square theta minus sin square theta. Cos square theta minus sin square theta is what? It's a formula of cos 2 theta. Cos square theta minus sin square theta is what? It's a formula of cos 2 theta. Okay. Next, v is equal to 2xy. So 2 into x is what? R cos theta into y is what? R sin theta. So r into r square. 2 sin theta cos theta will give you sin 2 theta. 2 sin theta cos theta will give you sin 2 theta. So we converted u comma v in terms of r and theta. So u x comma y he gave here actually. So we converted in terms of r and theta. Now, so therefore Jacobian of Jacobian dou of u comma v by dou of r comma dou of u comma v by dou of r comma theta is equal to mod. What is the formula, dou u by dou r, dou u by dou theta, dou v by dou r, dou v by dou theta. This is the formula, Jacobian formula for two variables, dou u by dou r, dou u by dou theta, dou v by dou r, dou v by dou theta, correct? So therefore this is equal to mod dou u by dou r, u with respect to r square is what? 2r I get here, 2r cos 2 theta, dou u by dou theta. So u with respect to theta, r square is as it is, cos 2 theta will give you minus sin 2 theta. Again chain rule differentiation of 2 theta is 2. Next, dou v by dou r square is 2r sin 2 theta as it is. R square is 2r, sin 2 theta is as it is. Dou v by dou theta, r square into sin 2 theta differentiation cos 2 theta into 2 theta is what? 2. Okay. So now what we have to find? We have to find the determinant here. So AD minus BC, 2r into 2r, 2r cube into 2, 4r cube cos square 2 theta. So minus of minus plus 2r into 2r r square, 2r cube into 2, 4r cube, 4r cube sin square 2 theta. So take out 4r cube common from both the terms. 4r cube common from both the terms. What I get here? Cos square 2 theta plus sin square 2 theta. Cos square sin 2 theta plus sin square 2 theta will give you 1. So what I get here? I get 4r cube. Understand here? So very important problem. Sometimes it will come for 2 marks and as well as sometimes it will come for long answer also. Understand here what we have to do? We have to change u comma v in terms of r and theta. We have to change u comma v in terms of r and theta. So u is equal x in place of x, substitute r square, r cos theta, r square cos square theta, minus r square sin square theta. R square is common. Cos square theta minus sin square theta is how much, cos 2 theta. Then v 2xy, 2x is r cos theta, y is r sine theta. So r into r square, 2 cos theta sine theta is what? Sine 2 theta. Then substitute Jacobian formula, simplify, you'll get the answer. Okay, see the next problem. Next problem, if u is equal to x square plus y square, v is equal to 2xy, find dou of u comma v by dou of x comma y. It's a small problem. It came for 2 marks problem, correct? So what we have to do, first of all, solution, given u is equal to x square plus y square, correct? Then v is equal to 2xy. So he's asking dou of u comma v by dou of x comma y. So therefore, Jacobian J is equal to dou of u comma v by dou of x comma y is equal to mod. What is the formula, ma? Dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. This is for Jacobian function formula to variables, right? So he gave u in terms of x and y, v in terms of x and y. So J is equal to mod dou u by dou x. With respect to x, you have to differentiate. X square will give you 2x, no x here 0. Dou u by dou y, no y here 0. Y square is 2y. Dou v by dou x is 1, you get 2y. Dou v by dou y is 1, you get 2x. So AD minus BC, 4x square minus 4y square. Take out 4 common, x square minus y square. So important is what you have to remember the formula first of all. So you have to remember the formula. So multivariable calculus, we have so many methods. So we did differentiation. These all come under partial derivative only. Multiple variable calculus, 2 variables full complete will come a partial derivative only. Partial derivative, chain rule problems, then Jacobian problems, maxima and minima. All topics will come under partial derivatives only. Okay. See the next problem. The next problem, if u is equal to x plus y and uv is equal to y, u is equal to x plus y, uv is equal to y, then find dou of u comma v by dou of x comma y, he's asking. So what he gave here, see, solution given u is equal to x plus y, okay. Then what he gave here, uv is equal to y, he says, u is equal to y. So what we'll do, so we'll substitute here u value. If I substitute here u value, so what is v from here? Y by u. So y by u is what? X plus y. So we have to change v full in terms of x and y, okay. So now u is equal to x plus y, v is equal to y by x plus y. So therefore, Jacobian J is equal to dou of u comma v by dou of x comma y is equal, what is the formula? Dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, correct? Now simplify here, mod dou u by dou x. Dou u is what? X plus y. If I differentiate with respect to x, I get x is 1. Dou u by dou y is 1. Dou v by dou x, you have to differentiate here 1 by x, so I'll get here minus y by x plus y whole square. Then again dou v by dou y, here also y is there, here also y is there, we get u by v formula. Separately we calculate, dou v by dou y is equal to u by v formula, x plus y whole square, x plus y into 1 minus y into 1. So y and y get cancelled, x by x plus y whole square, I get here x by x plus y whole square. U by v formula we have to do, so v square x plus y whole square, x plus y into differentiation of y is 1 minus y into x plus y differentiation, x is 0, y is 1. So the y and minus we get cancelled, x by x plus y whole square we get, x by x plus y whole square we get. Now, so determinant x by x plus y whole square minus of minus plus y by x plus y whole square. LCM is same, x plus y whole square, numerator x plus y, 1x plus y, 1x plus y get cancelled, so what I get here, 1 by x plus y we get. Understand here? It's a very simple problem. Only thing is you have to partially differentiate and you need to substitute in this formula and calculate the value of Jacobian. So Jacobian J is equal to what I got here, 1 by x plus y. Okay. Next, one more important problem. Find the Jacobian for u is equal to x plus y by 1 minus xy and v is equal tan inverse x plus tan inverse y. See here how it is a little bit a lengthy problem. Why? Because u is what function in terms of x plus y. X is in the numerator and denominator. Y is also numerator and denominator. So when we are differentiating dou u by dou x and dou u by dou y, we have to do u by v. Correct, ma? So solution given what he gave here, u is equal to x plus y by 1 minus xy. V is equal to what? Tan inverse x plus tan inverse y. Correct. So what we have to find? Jacobian J is equal to what is the formula? Dou of u comma v by dou of x comma y is equal to mod dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. This is the formula of Jacobian. Correct. Now substitute here. J is equal to, if I simplify, dou u by dou x. Dou u by dou x is what? U by v formula. Correct. U by v formula. So what we get here, if I do solve u by v formula, so can we solve here directly? See here, or you can separately find out and you can substitute, or you can solve here also. Otherwise, we'll do one thing. We'll solve separately and we'll solve it here. So dou u by dou x. Dou u by dou x. What we get here? See, dou u by dou x, u by v formula, right? V square 1 minus xy whole square, v into 1 minus xy into differentiation of u. U is what? X is 1, x is 1 minus minus x plus y into differentiation of 1 minus xy. 1 is 0, x is 1, I get minus y. So what I get here? 1 minus xy, minus into minus plus xy minus y square, I get minus into minus plus y square. So minus xy plus xy got cancelled. So what I got? 1 plus y square by 1 minus xy whole square, I got 1 plus y square by 1 minus xy whole square, I got ma. So therefore 1 plus y square by 1 minus xy whole square. So similarly, dou u by dou y, what I get here? 1 plus x square by 1 minus xy whole square. If you want, you can solve it. It's not like that. I just want, if you want, you can solve it, ma. Okay. Next, tan inverse v. V differentiation with respect to x. Tan inverse x differentiation is what? 1 by 1 plus x square. Tan inverse x differentiation is what? 1 by 1 plus x square. Then tan inverse y differentiation is what? 1 by 1 plus y square. V with respect to x here, this part is 0. V with respect to y, this part is 0. Tan inverse y is what? 1 by 1 plus y square. Okay. So now you have to find determinant here. If you find the determinant here, what I get here? So therefore this into this, right? Jacobian J is equal to AD minus BC. No, I get here 1 plus y square by 1 minus xy whole square into 1 plus 1 plus y square. Correct, ma? Minus 1 plus x square into 1 plus x square into 1 minus xy whole square. See here, so this part get cancelled. This part get cancelled. 1, 1. So again, 1 by 1 minus xy whole square, 1 by 1 minus xy whole square, again get cancelled. Correct? What is left here? 1 by 1 minus xy whole square, 1 by 1 minus xy whole square. So this part get cancelled. It is what? 0. Very, very important, ma, this problem. So sometimes it will come for 4 marks. Sometimes it will come for 2 marks also. Okay. So Jacobian basically basically he will give you, if your paper is easy, it will come for 7 marks. Otherwise he will give you 2 marks and all like that. Okay. So understand here. So what we have to do, u is in terms of x and y, numerator and denominator, both u. Whenever the function is in terms of numerator and denominator, you have to do u by v differentiation. Okay. So this is u by v formula, and substitute in the problem, you will get the answer. You got 0 over here. Okay, very important problem it is. Okay. Next, if x is equal to u into 1 minus v, y is equal to uv, prove that j into j dash is equal to 1. Prove that j into j dash is equal to 1. Okay, ma? How to solve here? See here, given x is equal to u minus uv, multiply this u, and y is equal to uv. So he's asking j into j dash is equal to how much we have to prove? We have to prove 1, correct? So therefore, j is equal to dou of x comma, now x is in terms of uv, y is in terms of uv, correct? So j is equal to dou of x comma y by dou of u comma v. So it becomes dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. So what I get here, mod dou x by dou u ma, x with respect to u. So u is 1 here, u is 1, I get v. Then x with respect to v, no v here, 0. V is 1, I get minus u. No v here, 0. V is 1, so I get minus u. Next, dou y by dou u. U is 1, I get v. Dou y by dou v. V is 1, I get u. So j is equal to, if I find the determinant, what I get here, 1 minus v into u minus uv minus uv minus of minus plus uv plus uv got cancelled. So j is equal to u. What is the value of j? J is equal to u I got, correct? J is equal to u. One second, what happened to this? So now he's asking j dash. J dash is equal to what? 1 by j. That means 1 by u. This implies j into j dash, u into 1 by u. U and u got cancelled. How much we got? 1. That only we have to prove, right? So important here, Jacobian. So j into j dash is what? 1. This is for 2 marks problem. Next, another problem. If x is equal to e power r secant theta, y is equal to e power r tan theta, then prove that j into j dash is equal to 1. So what is x he gave here? E power r into secant theta. R and theta he gave. Y is equal to e power r into tan theta. So j is equal to dou of x comma y by dou of r comma theta. Dou of x comma y by dou of r comma theta, dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta you have to find. Correct? So now differentiate here. If I differentiate here, mod x with respect to r. So e power r is what? As it is e power r into secant theta. So dou x by dou theta. E power r is as it is. Secant theta differentiation is what? Secant theta into tan theta. Next, dou y by dou r. E power r is what? E power r. Tan theta is as it is. E power r is as it is. With respect to theta, tan theta differentiation is what? Secant square theta. Tan theta differentiation is what? Secant square theta. Now, find the determinant here. E power r into e power r, e power 2r secant cube theta minus e power 2r secant theta into tan square theta. So take out e power 2r secant theta common. So what I get here? Secant square theta minus tan square theta. Secant square theta minus tan square theta is how much? How much it is? It is 1. So this value is 1. So I get here e power 2r into secant theta. This is the value of j. Now what is j dash? J dash is equal to 1 by j, right? So e power 2r secant theta. Yeah, if it is for 2 marks, you can solve like this. If it is for a long answer, you find out dou of r comma theta with respect to dou of x comma y. Then it will go for very lengthy. Then you will simplify here. So 1 by j is equal to what? 1 by e power 2r secant 2 secant theta. So therefore, j into j dash. What is j I got? E power 2r secant theta. What is j dash we got? 1 by e power 2r secant theta. Both will get cancelled. You get the answer is 1. Understand here? So, so j dash is equal to 1 by j, basically the formula. So simplify and substitute here. You will get the answer. Okay. So this is the problem on x with r and theta he gave here. Okay. See the next problem. Next, if x is equal to r sine theta cos phi, x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, z is equal to r cos theta. So we have to find dou of x comma y comma z by dou of r comma theta comma phi. Okay, ma? So this is the x, y, z in r theta phi he gave here, correct? Jacobian for three variables, ma. Jacobian for three variables. So what he gave here, this is a little bit lengthy problem. Given x is equal to r sine theta cos phi, comma y is equal to r sine theta sine phi, z is equal to r cos theta, correct? This is the given values, right? So now what we have to do here, see, so first what we have to find, okay, write the formula. Jacobian J is equal dou of x comma y comma z by dou of r comma theta comma phi is equal. So it's a lengthy formula, right? So I am differentiating directly, ma. So dou x by dou r. If I differentiate dou x by dou r is 1 here. I get sine theta cos phi. What I get here? Sine theta cos phi. Next, dou x by dou theta. So sine theta differentiation is what? Cos theta, r cos theta cos phi, right? R cos phi is as it is. Sine theta differentiation is what? You write the formula. I didn't write the formula. You write the formula. So next, x with respect to phi, cos phi, r sine theta is as it is. Cos phi will give you minus sine phi. So what I get here? R sine theta minus sine phi. R sine theta minus sine phi I get here, right? Next, y with respect to r. Y with respect to r is 1. What I get here? Sine theta, sine phi. Next, y with respect to theta, sine theta differentiation. R sine theta will give you cos theta, sine phi. Y with respect to phi, sine phi will give you cos phi. R sine theta, cos phi, right? Next, z with respect to r is 1. I get cos theta. Z with respect to theta, cos theta is minus sine theta. So Z with respect to phi, no phi there, it becomes 0. No phi there, it becomes 0, correct? Now you have to find the determinant mass. Okay, it's a lengthy problem. So sine theta cos phi, we have to leave this row and this column. This row and this column, AD minus BC. So this into this 0, minus of minus plus r square sine square theta cos phi, r square sine square theta cos phi. Next, minus r cos theta cos phi, bracket begin, this row, this column, 0 into this part is 0, minus this into this, r sine theta cos phi. Okay, r sine theta cos phi. Next, last this one, minus r sine theta sine phi, bracket begin. We have to leave this row and this column, this and this, minus r sine theta into sine theta sine square theta sine phi, minus r cos square theta sine phi, correct? Now simplify here. If I simplify here, okay, what will get here? 1 second. Multiply here. So what I get here? R square sine cube theta cos square phi, minus into minus plus r square sine theta cos square theta cos square phi, minus into minus plus r square sine cube theta sine square phi, minus into minus plus r square sine theta cos square theta sine square phi. Okay. See any common, ma? So we can take common here and here. What we can take common? From here and from here, we can take common of r square sine cube theta is common. I get cos square phi plus sine square phi, right? From here and here, what we can take common, ma? R square sine theta cos square theta common. I get cos square phi plus sine square phi. So cos square phi plus sine square phi is what? 1. So this part also been 1. So what is left? R square sine cube theta plus r square sine theta cos square theta is left. So what we can take common over here again, r square sine square theta, sine theta is common. If I take common, so I get here sine squared theta cos squared theta. R square sine theta common, sine squared theta is left, r squared sine theta is common, cos squared theta is left. Sine squared theta plus cos squared theta is how much more? 1. So I get r square sine theta is the final answer. Okay, like that you have to differentiate. I didn't write the formula, you just write the formula and again differentiate, substitute and simplify. Very simple problem. See, whenever you are writing the exam, if lengthy problems will come, you have to solve very quickly so that you can save the time and all. Okay, we'll go for another problem. Next problem, this is also important problem here. See, so what he gave here, if u is equal to x plus y plus z, what he gave here, u is equal to x plus y plus z, uv is y plus z, z is equal to uvw. He is asking Jacobian of x comma y comma z by u comma v comma w. Correct? So first you have to separate. Combinations are given here. First you have to separate it, ma. So what do we have to do? Given u is equal to x plus y plus z. Correct? Now uv is equal to y plus z and z is equal to uvw. Now I need xyz values in terms of uvw. Xyz values in terms of uvw. So now what I get here, see, u is equal to x plus y plus z. What is y plus z value, ma? uv. Substitute here, uv. So uv will come this side. X is equal to u minus uv. So I got x in terms of u and v. Next, here uv is equal to y plus z. Z is equal to what? uvw. So uv is equal to y plus uvw. So y is equal to uv minus uvw. Right? So next, z is equal to uvw is as it is. So what I did here, we find the values of x, y, z in terms of uvw. Correct? Now, therefore, Jacobian J is equal to, what is the formula? XYZ in terms of UVW, right? So dou x by dou u, dou x by dou v, dou x by dou w, dou y by dou u, dou y by dou v, dou y by dou w, dou z by dou u, dou z by dou v, dou z by dou w. Correct? So changing in terms of UVW is very important. XY, Z, we have to convert in terms of U. That is very important. Now, X with respect to U. U is 1 here, I get 1. U is 1 here, I get V. Correct? With respect to V, no V here 0. V is 1, I get minus U. No W here, I get 0. Next, y with respect to u, ma. Y with respect to u. So u is 1, I get v, minus u is 1, I get vw. Y with respect to v. V is 1, I get u, uw. W, no w here is 0. W is 1, I get minus uv. What I get here? Minus uv. Next, z with respect to u is 1, I get vw. With respect to v, uw. With respect to w, uv. Correct? Now find the determinant here. 1 minus v into, we have to leave this row and this column. This into this. U into uv, I get u square v minus u square vw. Minus of minus plus u square vw. Minus of minus u. This row, this column we have to leave. Ma. This into this uv square w. This into this, minus of minus plus uv square w. Last part 0 into anything is what? 0. 0 into anything is what? 0. Correct. Now see here, minus u square vw plus u square vw get cancelled. Minus uv square w plus uv square w get cancelled. Multiply here, 1 into u square v minus u square v square, minus into minus plus u square v square. So minus u square v square plus u square v square, it cancel. What at the end I got? U square v. That only we have to 2. Correct. See, in exam, don't do like this. You have to write stepwise, little bit lengthy, because see, this screen is small. I adjusted here, but in the exam you write here, and you can solve it if you want separately also. If it come for 7 marks, no, you can solve it here. X partially differentiate with respect to u v w separately, partially differentiate y u v w separately, partially differentiate z u v w separately. Then write the formula. Then it will go for 1 or 2 page. Correct, 1.5 page like that it will come. So here the screen is small, so that's what I explained little bit. Adjusting the screen and all. Okay, understand here. So very important problem. First, what we have to do, we have to convert we have to convert UVW. You have to convert x, y, z in terms of UVW. So u is x plus y plus z. Y plus z value is what? UV. I substituted here UV. I took this side u minus UV. Then here UV is equal to y plus z. Z is UVW. I wrote here. Then I got y value. Then z is already in terms of UVW. Correct. So Jacobian J is equal three variable formula. Write it here and simplify. Find the partial derivatives of x with respect to UVW, y with respect to UVW, z with respect to UVW, and simplify. You will get the answer as u square v. Okay. Okay. Well, next problem. Next. Right. Next very important problem. Prove that the functions u is equal to x plus y plus z, v is equal to xy, yz plus zx, w is equal to x plus y plus z are functionally dependent, he's asking. Functionally dependent, and find the relation between. What is this new term in Jacobian, functionally dependent? Any function Jacobian is 0. If you find the Jacobian of given functions, so if you find the relation between, if you find the Jacobian of given functions, if you get the 0, so Jacobian J is equal to 0, then those the functions are called functionally dependent. Functions are called functionally dependent, right? Now see whether we get 0 or not. First, what he gave here, given u is equal to x plus y plus z, v is equal to xy, y plus yz plus zx, and w is equal to x plus y plus z. X plus y plus z he gave here. Correct. Now you have to find Jacobian. So Jacobian J is equal to mod dou u by dou x. Dou u by dou x, right? X is 1. No x here, 0. Dou u by, shall I write the formula? One second, I'll write the formula. So, you know the formula, three variables, no, anyhow, right? Dou u by dou x is 1, dou u by dou y is 1, dou u by dou z is 1. V with respect to x, x is 1, I get y and plus z. V with respect to y, I get x plus z. V with respect to z, I get y plus x. W, x, y, z. W is what? X plus y plus z. 1 second. Oh, sorry. W is x square, y square, z square. W is what? X square, y square, z square. Sorry. So W will give you 2x, y square will give you 2y, z square will give you 2z. Right? This is the Jacobian we calculated. Right? Correct. So u with respect to x, u with respect to y, u with respect to z, v with respect to x, v with respect to y, v with respect to z, and w with respect to x, y, z. Correct. Now, so j is equal to what I get here, 1 into this row, this column, multiply what I get here, 2xz plus 2z square minus 2y square minus 2xy. Okay. So this is the thing, right? Okay. This will become a little bit lengthy. Minus 1 into, now this row, this column we have to find. So 2yz plus 2z square, this into this, minus 2xy minus 2x square. Okay. Plus 1 into this row, this column, 2y square plus 2yz minus 2x square minus 2xz. Correct. So now see here, plus 2xz minus 2xz got cancelled, plus 2z square plus 2z square minus 2z square got cancelled, this minus, right? Minus 2y square plus 2y square got cancelled, minus 2xy, minus into minus plus 2xy got cancelled, 2yz minus 2yz plus 2yz got cancelled ma. Minus 2 minus of minus plus 2x square minus 2x square got cancelled. So this is equal to what? 0. Got 0. Correct. So therefore, if Jacobian of any given functions are 0, so therefore u and vw are functionally dependent. So therefore u, v, w are functionally dependent, right? If Jacobian is 0, so therefore UVW are functionally dependent. Now what we have to find is asking the relation ma. If asking the relation. Now see here, W, what is the W he gave here? X square plus y square plus z square he gave here, and U is what? X plus y plus z. So if to find the relation, if I take U square, what is U square? X plus y plus z whole square. Expand it, I get x square, a plus b plus c whole square, x square plus y square plus z square, 2xy 2yz plus 2zx. Correct ma? So u square is equal to x square plus y square plus z square is what? W. Take out 2 common, xy plus yz plus zx is what? V. So w plus 2v. So therefore u square is equal to w plus 2v is a functionally relation between this UVW mark. Understand here? First you have to find Jacobian. If you get a Jacobian is 0, is called functionally dependent. Then see the values and apply the formula. You will get the relation between UVW. U square is equal to, what is the relation you got here? U square is equal to W plus 2V. Understand here? So these are the problems on Jacobian. I think we covered all the different type of models of Jacobian ma. So many problems. We did 9 problems in the previous video, 3 problems. So total 12 problems were available in the video. Please go through it and practice it. You will get the perfect in this Jacobian topic ma. Thank you.